All right, ladies and gentlemen, we are going to start by solving one-step equations with one variable using addition or subtraction. The first thing we have here is we have an equation. And what's different about an equation than an algebraic expression, what we've worked with in the past, is that an equation is a mathematical statement that two expressions are equal. Okay. An equation is a mathematical statement that two expressions are equal. So on the left-hand side here we have the expression x plus 8, and on the right side we have the expression 5. And an equation says that those two things are equal. All right, what we're going to do is solve for the variable x that makes this equation true. So let's talk about a few things here. The first thing we have to do is to isolate the variable. And to isolate the variable means to use inverse operations to move everything to the other side of the equal sign. Or to undo the operations that are happening to x. All right, so these inverse operations, again, they are operations that undo. In this case, we have x plus 8. 8 is being added to x. The way we undo that is we subtract 8. Now, what we've talked about today, hopefully in class if we had time, was that we have to keep equations in balance. Because of this equal sign right here, whatever we do to one side of the equation, we have to do to the other side. So to balance an equation, you do the same thing to both sides. And that's very important. We have to keep our equations in balance. Keeping an equation in balance is one of the major rules of Algebra 1. All right, so after we do that, after we subtract 8 from both sides, we're left with this side being just the variable x. Positive 8 and negative 8 cancel each other out and become 0, so we're just left with x on this side. On the right-hand side, however, we have positive 5 minus 8 is negative 3. That is our solution. The solution of an equation is a value of a variable that makes an equation true. The good news is you can check your solution. The way we check a solution is we plug the value for the variable back into the main equation. We plug, or substitute, the solution back into the main equation, the initial equation. So let's check this one. Let's plug negative 3, or substitute negative 3 into our initial equation. And we ask ourselves, is the equation true? Well, the left-hand side is negative 3 plus 8, which is positive 5. And we ask ourselves, does that equal the right-hand side 5? The answer is yes, it does. They're equal. All right, so this equation, x plus 8 equals 5, was solved by using the inverse of addition, which is subtraction. Question 1 asks us, what is the inverse operation of subtraction? In other words, what's the opposite of subtraction? My guess is you're very familiar with the idea that addition is the opposite of subtraction. Okay? On number 2, it asks us, if you add 5 to the right-hand side of an equation, how do you keep the equation balanced? Remember, up here we talked about an equation must be balanced, so you do the same thing to both sides. So in this situation, you'd have to add 5 to the left-hand side of the equation as well. The last question on the front here is, how do you isolate the variable in the equation p minus 4 equals 12? Well, in this situation, I have to undo subtraction or undo this minus 4. The way I'm going to undo that is the inverse operation of adding 4 to both sides. When I do that, I will get p equals 16. So how did I isolate? I add 4 to both sides. Very good. All right, that's all we're going to do with solving a variable with addition or subtraction. We're going to save the problems on the bottom for class tomorrow. If you'll flip your paper over, you will see that we are now going to solve one-step equations with multiplication and division, and it's done very similarly. The first problem here, we have -3 times x equals 12. So if I'm going to use an inverse operation to undo multiplication, and that's what's happening right here, I have -3 times x. So I want to undo multiplication, and as you can guess, the inverse operation of multiplication is division. So what I'm going to do is divide both sides by -3. And I have to do it to both sides because, again, I have to keep my equation in balance. That is the major rule for Algebra 1. When I look at this, I now have -3x divided by -3. I can reduce this fraction. The -3's will cancel out and become the number 1, like I want them to. So the left-hand side is now just x. The right-hand side is 12 divided by -3, which is -4. Again, I can check my solutions just like I did on the front by substituting them back in. So let's go back to the initial equation and plug in -4, or substitute in -4 for x, and see if my equation holds true. My left-hand side is -3 times -4, which is positive 12, and yes, that does equal the right-hand side, positive 12. So my solution is x equals -4. My next problem, I have x divided by 2. Remember, the fraction of x over 2 is just division of x over 2. The inverse operation of division is, you guessed it, multiplication. So how am I going to get rid of this division by 2? I'm going to multiply both sides of the equation by the number 2. My left-hand side, if you want to think of it as 2 over 1, I'm going to have 2x over 2, and the 2's will cancel, leaving me with 1x. My right-hand side is simply 12 times 2, which is 24. So x equals 24 is my solution. Again, I can check that by substituting 24 back into the initial equation. I have 24 over 2 equals 12. 24 divided by 2 is 12. My equation checks out. The next one shows the fraction -3/4 x equals 12. Well, we had a fraction here. This is basically, I could have written this if I wanted to, as 1/2 x. Okay? But this is a tad more complicated. When I have a fraction, it is multiplication and division at the same time. It's almost like I'm saying -3 times x, divide all that by 4. Well, the inverse operation, the easiest way to handle a fraction before your variable is to multiply by its inverse. Okay? So the inverse operation in this case is multiplying by the inverse of the fraction. Okay? So let me get this out of the way here. I'm going to take my fraction of -3/4. I'm going to flip it over and multiply by the inverse. My inverse is -4/3. And I have to do that to both sides. All right? When I do that, when I have -4/3 times -3/4, the negatives are going to cancel, The 4's reduced, the 3's reduced. I'm left with the number 1, x, on this side. On the right-hand side, if you want to think of it as 12 over 1 times 4 over 3, you could reduce if you'd like. The 12 and the 3 reduce to be 4 and 1. So I'm left with negative 16 in my numerator and 1 in my denominator. I'd like to show you another way to think about this. Negative 3/4 x equals 12. If you want to think of the negative 3/4 times x, you can think of dividing by negative 3/4 on both sides. Okay? Now, on this side, you have negative 3/4 over negative 3/4. We know that's going to cancel out and just become 1. Look at it on this side. I have a fraction inside of a fraction. We talked about how to deal with that. If you've got a fraction over a fraction, you take the inverse of this and multiply. So I'm going to multiply by that flipped over. And look where I'm at. I'm back where I started up here. I've got 12 over 1 times negative 4 over 3. I get the same answer, negative 16. So you can think of that problem either way. All right, what we're going to do in class tomorrow is we're going to practice these problems here at the bottom and the problems at the bottom of the front. I'd like you to leave them alone though and just let your brain dwell on this tonight, not work the problems. We'll do them in class together. Thank you so much.